guys, so we're going to find sector area and arc length. Okay, arc length is going to be different than measure, and we'll talk about that in just a few minutes. You guys have already found your arc measure. Now we're going to do the length of an arc. You guys are going to have a couple formulas here. You already know them. We just have to think about them in terms of a percentage of our circle. Okay, your sector of a circle is basically a slice of pizza. All right, it's the region bound by two radii and their intercepted arc. Okay, so this region bound by two radii and their intercepted arc right here. Okay, in order to write it, you write sector ACB. Okay, sector ACB. And the area of this, there's your area of your circle, pi r squared. However, we're just taking a percentage of it. Okay, remember your arc measurement is the same as your central angle. Okay, that's where your m degrees comes from. And you're dividing that by 360 to get a percentage of the circle. Okay, so we'll say percentage of circle C here. And that's how you're going to remember it instead of getting bogged down with all these letters. Let's go through a problem. We'll just do A. So we want to find the area of sector MNP. We want to find it in terms of pi and to the nearest hundredth. You guys are going to do both on your homework. It's good practice for you to do it in terms of pi. Get away from the calculator a little bit, and you guys are going to see it go back and forth on your homework and on your test and quizzes. Okay, so let's go ahead and let's put our formula down. Area of a sector is pi r squared. M degrees over 360 degrees. We're going to pop it into our formula, so we get pi 3 squared. M degrees, of course, is going to be 80 degrees. That's your measurement of your sector over 360. Okay, so we're doing the area of the circle, but we're just doing a percentage of it. All right, we want to leave it in terms of pi. This is a 9, 360. This turns out to be 1 over 40. 80 over 40 is going to be 2, so you get 2 pi. Okay, we're in inches. It's area, so we're going to do inches squared. And then round to the nearest hundredth, we're going to throw it into our calculator, and you get 6.28 inches squared. Okay, so here are your two answers. So here's another problem, guys. We'll go through this. Just a more of an application problem. A circular plot with a 720-foot diameter is watered by an irrigation system to the nearest square foot. Okay, so we're just going to round it to the nearest foot. What's the area that is watered as the sprinkler rotates at an angle of 50 degrees? Okay, so we want to find the area of this sector. Pi r in this case is going to be 360. We're cutting that in half, squared, times 50 degrees over 360 degrees. So the difference is just pay attention to your diameter versus your radius. It says to the nearest foot, so we're just going to throw this whole thing on our calculator, and you're going to get approximately, depending if you're using your pi button or putting 3.14 in. I would recommend using your pi button, guys. That way it's going to be a little more accurate on your calculator as opposed to putting 3.14 in. But if your numbers are a little bit off, and I see this, and I'm going to understand that, okay? All right, so now we're going to put some things together that you've seen before. We want to find the segment of a circle, okay? The segment is going to be this sliver right here. It's a region bounded by an arc and its chord, okay? So the arc and its chord. Now, here's our strategy. We know how to find the area of a sector, and we also know how to find the area of a triangle. So I'm going to do the area of the big guy minus the area of the little guy, and that's going to be what's left remaining. That's what this tells us right here. Okay, the area of a segment. Now this is a segment of a circle, guys, not a segment that you're used to. So you have to keep your head straight on the notation with this. Okay, so make sure you write this definition down and know it so that you don't get thrown off on your test. All right, so the area of segment is going to be the area of the sector minus the area of a triangle. All right, and you don't need to memorize, just think it through when you see it. It'll be one less thing to think about in your brain, or to bog your brain down with. Okay, so let's go through this example. We're going to go through a couple of these, just so you guys can see some different techniques. Find the area of a segment ACB. Okay, so this is segment ACB, this little sliver to the nearest hundredth. All right, so step one, we want to find the area of the sector minus the area of the triangle. And that's going to give us the area of a segment, just like we said before. Okay, so the area of the sector for this, guys, is going to be pi, I guess my calibrator right there, pi r squared, all right, and then do the percentage of that circle. 60 degrees over 360. So that's the area of the sector. Now this is what we have to be careful with, guys, the area of the triangle. Okay, let's look at this triangle here. We're just cutting this piece out and we came down here. Well, we know that this is going to be equilateral because these guys right here are, the radii are going to be congruent. All right, these are going to be congruent, which are going to make these congruent. That means that this is 60 degrees and this is 60 degrees. Okay, so if I take my hypotenuse, remember the area of a triangle is 1/2 base times height. I'm sorry, I should have said height, not hypotenuse. This is your hypotenuse. All right, so I'm going to do 1/2 and then my base times my height. Okay, well, this is going to be 6, cutting that in half. You know this has to be 12 because this is 12 and this is 12. So that's 12. Well, this is a 30, 60, 90 triangle, you guys. Okay, so this is going to be 6 root 3. X, 2x, x root 3. Okay, so that's where I got those values from. Now I'm just going to plug it right into my formula. 1/2 base times height. Now it's telling us to round to the nearest hundredth. If you want to go ahead and make this a decimal here, that's perfectly fine. Okay, my calculator is going to do all the work for me, guys. So I'm basically, this simplifies to 24 pi. Or again, you can throw it in your calculator and make a decimal. This is going to simplify to 36 root 3. Throw it in your calculator and you get 13.04 approximately inches squared. Okay, so not crazy. However, watch out for this. This is a little bit of a blast from the past. Okay, now, and again, we needed to have our base times our height. That's why we had to use that altitude. So let's look and see how this one's different. Find the area of the segment. Okay, well, this is 90 degrees here. That means that this is going to be 90 degrees, the arc measurement. So I'm going to go ahead and I'm going to do my area of my sector first. Pi r squared times 90 degrees over 360 degrees minus 1/2 base times height. Oh, this is a nice little problem. 1/2, I'm looking at this triangle here, guys. All right, you can just take this triangle and turn him on his head. Base. I just rotated him. All right, what's my height? Oh, that's a radius, that's 4. Oh, that's a little bit more palatable than the other one. All right, 1/2 base times height. And then I'm gonna let my calculator do the work for me, and I end up getting approximately 4.75, we're in meters squared. 4.57, I mean, meters squared. Okay, so this is the concept you just have to kind of be careful with. All right, last thing, guys, and this really piggybacks on what we talked about at the beginning of class. So we talked about arc measurement the other day, and the measure of the arc is the degrees of the central angle, okay? The length is the distance along the arc, all right? So think about it like this. With measurement, how many degrees are in a circle? 360 degrees are in a circle. With arc length, we're talking about how much I took a stroll around the block, okay? So with arc length, we're doing a piece of the distance around the circle, okay? So how do I find circumference? 2 pi r, all right? And then we're just doing a percentage just like we did before, okay? So you don't need to memorize anything, you just didn't think about it that you're doing a percentage of the circumference. Okay, so let's look at example 4 here. I want to find each arc length. All right, give your answer in terms of pi and round to the nearest hundredth. All right, so I have 2 pi r, my radius is 10. Careful if it's giving you diameter or radius. And I want to find the arc length of CD. So the measurement of CD, if I made an angle, would be 90 degrees. I want to find the length. I want to find the distance. So in this case, I'm just going to do 90 degrees over 360 degrees. Oh, no, not square because I'm not doing area. And simplify it and you end up getting 5 pi feet. Okay, so that's in terms of pi. And then my calculator is going to do the work for me, which is approximately 15.71 feet. All right, and there's your round to the nearest hundredth in pi. Okay, so these are really straightforward, you guys. You're just popping it right into your formula. Okay, the main thing is knowing the difference between your 2-unit piece of the circumference versus the measurement of the arc. All right, guys, that's all we got. We'll work on this in class.